Good morning. This is your stats sensei, Mr. Spensei, and this is the Unit 2 Death Packet on displaying and describing data, and this will be problem 61 to 70. Which of the following is a true statement? Whether or not to provide a key depends on the relative importance of the data being displayed. No, you provide a key all the time, regardless. Stem plots are useful for both quantitative and categorical data. That's false. Not useful for categorical. We use it for quantitative. Stem plots are useful for very small and very large. Almost impossible to use for very large. Great for small. Matter of fact, they provide more information than any other data for small. Stem plots can show symmetry, gaps, cluster, and outliers. That is true. All right. So 61 is D. Which of the following statements is true? Displaying outliers is less problematic when using histograms than when using stem plots. That's false. Stem plots and histograms do a good job with that. Histograms are more widely used than stem plots or dot plots because histograms display the values of the individual. Um, um, let's go back to A. Displaying outliers is less problematic. No, they're equally good. There's not a problem there. Histograms are more widely used in stem plots or dot plots because histograms display the values of individual observations. They do not. Stem plots do, so that's a false statement. Unlike other graphs, histograms axes do not need to be labeled. That's a false statement. All axes must be labeled. A histogram of categorical variable can pinpoint clusters and gaps. You do not use histograms for categorical data, and you cannot have clusters and gaps with categorical data. That's only true with quantitative data, so that's false. Two students working with the same set of data may come up with histograms that look different. Yes, because bin widths can varies. All right, you could use a bin width of 5 or 10 or 20, and because you change the bin width, the histogram would look different. And that's how, when I say bin width, I mean how wide the column is. Number 63, a study of 35 city high schools gives the following back-to-back stem plots. It's the percentage of students who say they have tried alcohol. So here we have 12% and 29% and 33%. Then we come back and check in 98, a couple years later. And we start off at 31 and 38. Which of the following cannot be supported? All right. In general, the percentage of students trying alcohol seems to have increased. And it looks like, yeah, it does look like it increased. So that looks like a true statement. And it says does not follow. So the key word here is not. The median alcohol percentage among the 35 schools increased from 1995 to the second graph. Yeah, we definitely see that it shifted this way. And I don't have to put the data in to see that this one has shifted further down. So it's definitely shifted. The spread between the lowest and highest alcohol percentage decreased from 95 to 96 to 98 to 99. That one I have to check. And so here I see 90 minus 12 is 78. Over here, I have a high of 92 minus a low of 31. And 92 minus 31 is 61. So that definitely went down. So the spread appears to have changed. So that's a true statement. For both school years in most of the 35 schools, most of the students said they had tried alcohol. And if we look at it, it's like, yeah, most of the schools, here's 50%. And it's like, well, 52, and I look at this, it's like, well, this thing is definitely less than half. Obviously, here we're even more, a lot more than half. So, because it's more than half in each case tried it. The percentage of students trying schools increased in each of the schools. This is a tricky question because if I look at this school and I go, okay, this is school at 41%. I don't know if they went up to 43 to, to 50, or whether they actually went down. I have no idea where that school is now located on this stem plot. I know that they were at 41 here, but I don't know where they are here. So it's possible that somebody went down, that not everybody went up. I know on average we went up. I know that in general we went up, but I don't know about any individual school. This statement is false because I don't know where the individual school, how the individual school changed. Number 64. A doctor wishes to compare the resting heart rates of his younger patients, younger than 30, versus his older patients, older than 30. Which of the following graphical um, displays is best? All right. So in this case, we're looking at I'm just going to tell you use a scatter plot because we're going to have we're going to measure the we're measuring their heart rates versus their age. Since we're measuring heart rates versus age, each individual is going to have an X and Y. And because they're going to have an X and Y can only be done with a scatter plot. All right. So the best way to do this would have been with a scatter plot. By the way, not on this test. A survey to measure job satisfaction of high school mathematics teachers was taken in 1993 and repeated 5 years later in 1998. Each year, a random sample of 50 teachers rated their job satisfaction on a scale of 1 to 100, with higher numbers indicating greater satisfaction. The results are shown in the table below. Okay, so what is the trend from 1993 with regards to the standard deviation? That's kind of hard to say with this and range of the two samples. This one appears to be more and more centered on a value. And because it appears to be centered, I'm going to say that this has a smaller standard deviation because it has a higher center. So if it has a higher center, there's more data close to it. This one has a lot of data that's more spread out. So this one, in this case, I would say this has a smaller standard deviation, smaller standard deviation. And we always have to calculate our range. So our range here, our highest value is 90 and our lowest value is 15. So 90 minus 15 equals 75. That's our range here. Here, our highest value is 97 and our lowest value is 21. And when I subtract that, 97 minus 21, I end up getting a 76. So this has a larger range, but smaller standard deviation. Both the standard deviation and range increase? No. The range increased, but the standard deviation decreased. The standard deviation increased? No, it decreased. The range increased while the standard deviation decreased. That's my best answer. And that one's a bit hard. Most of the time, it's going to be more obvious in this. But I can look at this and go, hey, this has a very high center. So consequently, it has a smaller spread, smaller standard deviation. This one, it has a whole lot out at the edge. So it's going to have a larger standard deviation. In a group of 10 third graders, the mean height is 50 inches with a median of 47. So let's think about this. If we had a number line, we have 47 here, and that's our median. And we have a mean. This is our mean, and this is our median. All right. What is the median height of the combined group? I have no idea. We cannot we can't we need more information than this. All right, we need more we'd have to have every single individual in order to do this, even though we have 10 third graders and 50 10th, third graders, we have to know every single person's height in order to find the median. To find the median, you have to have every single value and be able to list them in least to greatest. We don't have that. We can't do anything like that. So we cannot find the median of the combined group because we don't have enough information. You have to have every individual value in order to find the median. 67. STEM plots are useful both for quantitative and categorical data. Nope, that's false. They're not useful for categorical. STEM plots are equally useful for small and very large data sets. Nope, not useful for large data set. STEM plots can show symmetry, gaps, and outliers. Yes, that's true. So our answer is C, which is 3 only. '68. Consider the following back-to-back STEM plot. And if I look, I have 3, 4, 8, 3, 4, 8, 0, 1, 2, 0, 1, 2. Oh, so this one, the second one is shifted back. The distributions have the same mean. No, I can tell you this. This distribution will have a smaller mean. This will have a smaller mean because it's shifted back. The distribution have the same median. No, this will have a smaller median because the whole distribution is shifted back. The interquartile range of the distribution to the left is 20 greater than interquartile range of the distribution to the right. I don't know. Let's take a look. This is at 23 and this is at 3. Oh, it's been shifted by 20. But if I add if I'm adding a constant, this is adding a constant, the measure of spread doesn't change, so IQR doesn't change. The distributions have these same variance. Yes, I added a constant. Measures of spread don't change. So adding a constant to all of these values means they have exactly the same variation. They have the same IQR, the same range, the same standard deviation, and same variance. So measures of spread didn't change because I added a constant. Number 69, using the most commonly accepted definition of outliers, a set has 5 outliers. If every value of the set is increased by 20%, how many outliers will there not be? Oh, guess what? 5. It didn't change. All right. Multiplying by it just means that everything's spread out the same percentage, so you have the same number. All right. Did not change it. Number 70. The STEM plot below shows ages of CEOs of a select group of corporations. Which of the following is a correct statement about the distribution? Well, I look at this and I go, hey, it's reasonably symmetric and mound shaped. The distribution is bell shaped. I like that. But it says not a correct. So this looks like a true statement. The distribution is skewed left and skewed right. You can only be skewed in one direction, and this is not skewed at all, so that is false. That's probably my answer. The center is around 60. I can look at this and go, you know what? Eyeballing it somewhere between 58 and 63. So yeah, that looks true. The spread is from 28 to 90. That's true. There are no outliers. I don't see any gaps, so there's obviously no outliers. So the only answer that could possibly be is B. All right. Thank you for watching, and I hope to see you on the next one. Thank you.